Do you know you need special methods to analyze indeterminate trusses? Trusses are pin-jointed structures where joints are pinned, load is applied at joints, and only tension and compression exist in members. In indeterminate structures, unknowns are more than equilibrium equations. In today's tutorial, I will solve one example on indeterminate trusses using flexibility method. For this lecture, you need to watch the lecture on flexibility method first. If you haven't watched it already, click on this side of the screen to watch it. Let's dive into it. Hey friends, if you're new here, I am Dr. Jawed Qureshi, a senior lecturer at a London university. On this channel, we explore technical and human skills to help us lead more productive, happy, and examine life. In this tutorial, I would like to cover the flexibility method for pin-jointed structures. I will solve one example. The pin-jointed frame shown in this figure 2, is pinned at A, whereas F is roller supported. For all members, L over AE length over AE is given 20 into 10 raised minus 2 millimeter per kilonewton. So L over AE is given to us. And the frame carries a vertical point load of 30 kilonewton at D, which is here. During construction, it was found that member BE was too short by 4 millimeter and it was forced into position. Calculate the member forces in BE and EF and show mathematically what is the effect of 4 millimeter imperfection on the forces in member BE. Now here it is talking about the imperfections. So we had this lambda which represents the frame imperfections. First of all, we have to determine which member needs to be removed and if this is statically indeterminate or not. What is SI for this? SI is equal to M plus R minus 2J. So M is number of members. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Reactions are 3, 1 pin and 1 roller. So 2 reactions at the pin and 1 reaction at the roller. Minus 2 times J. Joints are 1, 2, 3, 4, 5, 6. So 13 minus 12. SI is equal to 1. What is the purpose of finding SI? The main purpose is that we want to remove a member or we want to remove a support. This is statically indeterminate and we cannot remove a support because it has 2 supports and it will be difficult to remove a support. SI is equal to 1 means one member needs to be removed so that the structure is statically determinate and it is in equilibrium. So the way we have done it is here. So we will work out the system 0 and then we will work out system 1. So first of all, we have to remove one member, and what I've done is that I've removed this cross bracing, but you can remove any member which will not cause it to be unstable. So I cannot remove member ED because it will be unstable if I remove member ED. The safest option for me is to remove this member BE. So once you remove this member BE, then this system turns to be in a statically determinate structure. The next thing is to show arrows, and the arrows pointing away from joints show tension members. So I will show everything as tension. I will say that tension is positive. So initially I will assume that every member is in tension. So if I get any other direction than positive, then I will say these are in compression. So arrows pointing away from the joint, they indicate that it is tension. So these are arrows which are pointing away. And then these values, I will write these values as I go on. And reactions, VF is vertical force here and VA is vertical reaction at A. And horizontal reaction I'm discarding because it will not have value as well. So here summation of moments at A. So if you take summation of moments at A, then you will be able to find out at least reactions. So moments at A, first this VF force is creating some kind of moment with respect to A, and it is creating anti-clockwise moment. So VF times L is creating anti-clockwise moment, and then I have this 30 kilonewton. 30 times length from here to A is 3L. So that's why 30 times 3L, but this is creating a positive moment. So that's why it is positive. From here, if I bring it on the other side, this is 90L and L will get cancelled. So VF will be equal to 90. So if I have value of VF, I can find out value of VA. Summation of vertical forces equal to 0. VF is positive, minus VA is negative, minus 30 is equal to 0. VA will be equal to, if I bring VA on the other side, so VF minus 30. So VF is 90 minus 30. From here, VA is 60. First thing for me is to find out the member forces. Member forces in the real system. We will have virtual system as well. We will apply a unit load at this virtual point. So let us find out member forces now. We have reactions. Then we will say that summation of vertical forces at point D is equal to 0. We are starting with joint D. At joint D, this indicates vertical forces. So we are summing up the vertical forces. Now at joint D, I will have two vertical forces. One is 30 kilonewton. Other will be vertical component of this force DC, FCD or FDC. And its vertical component will be acting upwards. Both of these forces have direction which is opposite to each other. So when the direction is opposite to each other, then I can write it down on the other side of equation. Because the angle among all these members is 45, sine 45 is equal to cos 45, that is equal to 0.7007 or 1 over under root 2. So I will write these values directly. The vertical component of CD is FCD sine 45, which can be written as FCD 1 over under root 2. And this is equal to 30. So from here, I can find out value of FCD and then I can write it down here. And then at the same point, summation of horizontal forces equal to 0. Now this time, these horizontal forces are acting in the same direction. So I have FDE as horizontal force in this member that is acting leftwards, and I have a component of CD which is acting leftwards as well. Because they are acting in the same direction, so that is why I'm adding sim. And if you simplify this, you will get FDE as minus 30. All right, FDE as negative. It means that it is in compression. So our initial assumption was not correct. Then I will move to the next joint, which is joint E. Now this is very interesting that at joint E, I have no member. The force in CE is equal to 0. Because if I say that summation of vertical force is equal to 0, then there is no other vertical force. So that's the reason FCE is equal to 0. And then I have horizontal member. Now there are two horizontal members connected. So FED is equal to FEF. Both of them are equal and both have opposing directions. So that's why I have value of FED or DE. That's why using summation of horizontal forces equal to 0 will result in FDE equal to minus 30, which is here. Once I have done this, then I will move to joint C. The forces, member forces which are circled here, these are known to me. Now I will move to joint C and I will say summation of, first of all, vertical. This sign indicates vertical force. Summation of vertical forces equal to 0 at joint C. I have FCE, which is already 0. Simply, I would probably not take this into account, but I have already written it, FCE, that is acting downwards. All forces or components are acting downwards, okay, here. And then I have a vertical component of this force, FCD. Vertical component of FCD is FCD sine 45. And I have vertical component of FCF, which is FCF into 1 over under root 2. And I have FCE, which is acting downwards. So I have these three forces, vertical forces, acting at point C, out of which CD is known to me and CE is already 0. It means I can find out FCF. FCD into 1 over under root 2 is 30 because FCD is 30 under root 2. So if you divide it by under root 2, you will get 30. FCF is not known to me. FCE is already 0, so which is not written here. So again, if you bring it on the other side of equation, you will get FCF as minus 30 under root 2. So this is how we got this FCF. And then I will sum up the horizontal forces at joint C. Now joint C has two horizontal forces. One is BC, other is horizontal component of this force
CF. Both of them are acting in the same direction. So that's why I will add them up. And also I have this one, FCD, the horizontal component of FCD as well. Not only two forces, I have three forces. FBC is acting in the same direction as horizontal component of FCF. So I will say that FBC or CB plus FCF cos theta, which is equal to this one, they are acting towards left. And I have another horizontal force which is acting towards right, that is horizontal component of CD. That's why I have written it on the other side of equation. So horizontal component of CD can be written as FCD into 1 over under root 3. Now if you put value of CF, which is equal to minus 30 under root 3, and then if you put value of CD, which is 30 under root 2, so FBC minus 30 is equal to plus 30. So this 30, if you bring it on the other side of equation, FBC will be equal to 60 kilonewtons.
So this is system 0 with just the member BE removed, right?
Yes. And I summed up at joint C, I summed up vertical forces and I summed up horizontal forces. Now this has given me this force BC and it has given me CF as well. So CF I've already written over here. And now I will go to joint B. And again at joint B, force BF is 0 because summation of vertical force is equal to 0. There's no other vertical force shown here. So that's why this is 0. And horizontal force, summation of horizontal forces, these two forces are acting in opposite direction and there's no other member connected, so that's why this has to be 60 as well. So that is the reason I have FAB as equal to 60. FBC is equal to FAB and that is equal to 60. And then I will move to joint A. At joint A, I have reaction VA. That's the reason I found out reaction VA. All right, otherwise there was no need. I have this vertical reaction VA and I have this vertical component of force AF. And then from here you can work out FAF as minus 60 into under root 2. And then simply you write this over here. For system 1, what I will do is that simply I will replace BE with a unit load as 1. So I will replace this. This is the member that we removed from here and I will put 1 over here. You can say that summation of horizontal forces equal to 0 at this joint, which is joint E. Only two horizontal forces are acting here. One is FEF, other is horizontal component of this one force. So horizontal component of this force 1 will be equal to 1 into 1 over under root 2. That's why we have this minus 1 over under root 2. And then simply following the symmetry, you will have same load all across. So that's why I'm not calculating at other joints. If you want, I can show you details of this joint E. So at joint E, summation of vertical forces. Vertical forces are FEC or CE. This force is known to me. Now I'm applying this force 1 here, where I removed the member. So simply apply a unit load there. This is acting in the same direction. Vertical component will be FBE into sine 45 equal to 0. Both of these forces are acting upwards. So FCE plus FBE is given to me, which is 1, which is, I have applied load 1 here where I removed the load. So 1 times sine 45 is 1 over under root 2. This is equal to 0. So from here FCE, if I bring it on the other side, it will be minus 1 over under root 2. So if FCE is under root 2, similarly, if I say summation of horizontal forces equal to 0, it will give me minus 1 over 2. Because this is symmetric, it will give me these forces all across. And the reason we don't have any forces in the outside elements, because only internal forces are applied here. So that's why you will not have any loading in the outside elements. And then in the same way, you can work out these forces in all other elements.
A question.
Yes.
So when you construct system 1, the second system,
yes.
What are the differences between the two systems? So you didn't consider reactions and forces?
System 0 is a system where we remove one member. depending on SI. If SI is 1, remove 1 member. If SI is 2, remove 2 members. If SI is 3, remove 3 members. Our SI was 1, we removed 1 member and we applied the actual forces. System 1 is a system where we apply a unit load where we removed the member and we remove all other loads. The actual loads are not applied in system 1. Now at point D, you haven't got any forces. So that's why these are 0. And again here, you haven't got any forces. Even if you sum up these forces, only internal forces are applied. So that's why you have forces all along. And I've shown you one sample calculation. If you like, you can do the calculations for the entire bit, but still you will get the same answer. EF, you can find out value for BF. Or I would say they simply find one sample equation and then say that, okay, everything is equal to 1 over under root 2.
And then why is the value of CF different? Why is that 1 as opposed to?
Yes, because it is compatible with the inclined member. So that's why it's 1. But you can find it out from here actually. If you have these two values already. If I have found out these two values, then I can find out the other values as well. So if I consider joint C, so at joint C, summation of vertical forces are y component of FCF. So FCF times sine 45. And then I have FCE that is acting downwards as well. And this is equal to 0. Does it make sense or not?
Yeah.
At C, I have two vertical forces. One is CE that is directly downwards. Other is vertical component of CF. CE is known to me. FCF is not known to me. So FCF times sine 45. Sine 45 is 1 over under root 2. And FCE is minus 1 over under root 2. I can bring this on the other side of equation. FCF into 1 over under root 2 is equal to 1 over under root 2. All right. I brought this on the other side of equation. Now by cross multiplying, FCF is equal to under root 2 into 1 over under root 2. By cross multiplying, this and this will get cancelled. And I get FCF equal to 1. Okay.
Yeah. Okay.
All we need to do is simply use method of joints. So start from the point where forces are known, and you don't have to use this 1 over under root. I find it easier to do it that way, but if you want to put 0.707, by all means put it.
So technically we could use a method of joints for both system 0, system 1, right?
Yes, that's what we are using actually. So now I have determined member forces for both real system and virtual system. The principle of virtual work method, the purpose is to find out these deflection, and that D10 deflection, the formula for deflection is this summation of P dash, where P dash is your P1, P2, P3 virtual system, and P into L over AN plus lambda. So I will apply this formula to work out this deflection D10. The compatibility equation for method where we remove only one force is this one. That is D10 plus your redundant. Our redundant in our case is PBE, where we remove the member and apply a unit load times F11. So this is our compatibility equation for a situation where you have only one member removed. If you have two members removed, then you will apply other equations. Those equations are here. If you have two forces removed, then you will apply these equations. This is the equation for D10, where it is summation of P1, P0 L over AE, and plus you have this lambda, which is your imperfection. Now, what is P1? What is P0? P1 is a member force when we have virtual system. P0 is a member force when we have a real system. We have to combine all those. Our first job was to find out P0 for each member. And secondly, we found out P1 for each member in the system. Now we can add it up, can't we?
Yeah.
Our main purpose here for creating this virtual and real system is to put it into this D1 formula so that we can find out value of displacement. And then we use this D1 into finding the redundant, finding the force in the member which we removed. And finally, we find out the member force. And the formula for member force is this one. P is equal to P0 in that particular member force plus P1 into R1. R1 means the force that we have removed in redundant. In our case, R1 is this PBE, which we removed, or you can write simply R1 here. Now I'm applying this formula for D1 here, and I'm summing up forces in real system and virtual system. I'm adding up the imperfection. So let us first of all add up the forces. So how do we add up the forces? We have P naught and we have P1. We will start from here. We have real system and we have virtual system. And for each member, I will write down the real force and virtual force, and then it will help me adding it up. Okay. So for AB, the force in real structure is 60, which is written here. For the same point in virtual system, it's 0. And for BC, again, it's 60 here and 60 is written here. And in the virtual system, it is minus 1 over under root 2, which is written over here. So simply you write these forces in a table for all members. And then you multiply P naught and P1, these two tables. And then you multiply P1 with P1, right? The reason is that we need it for F11. And simply then you multiply it with L over AE. And L over AE for this problem is given as 20 into 10 raised minus 2. So this is P1, P1. So simply we write this in tabular format, all the forces in all the members in system 0 and all the forces in all members in system 1. And then we multiply P naught P1 to get this table, and this is equal to 90 over under root 2. Simply we add up P1 and P1. And then we have this compatibility equation, D10 plus whatever force you have removed. In our lecture notes, we term it as R, F11 equal to 0. Now we will find out D10 and F11 from these formula, the one that you see here from lecture notes. And finally, we will add up P naught plus P1 into R1 to find out the actual force in the member. P naught P1, we have 90 over under root 2. Then we multiply it with L over AE, which is given to us. And this minus 4 is negative because this is imperfection. And why it's negative? The reason is that because our members were too short. During construction, the member BE was too short by 4 millimeter and it was forced into position. Because this member was too short, it means that it has this imperfection as negative. If it was too long, then value of lambda is going to be plus. Now this will give me D10 as 16.78. This is with imperfection. So again, we have to work out this F11, for which we have, instead of P naught P1, you have this formula for F11. And here simply you have this value 4 and you multiply it with L over AE. And from here you get value of F11 as 0.8. And now I have value of F11, I have value of D10. Simply you put these values to find out the force. So once I have the force here, PBE, then I can find out force in pretty much any member. Here I'm asked to find out force in BE and EF. So I already have force in BE. So this is my R. This is my redundant. Use this R to find out any member force. So for example, if I wanted a member force in AF, then member force in AF would be this P naught plus its P1 times R. If I wanted to find out member force in say BC, then it would be P naught plus R times this P1. This is how we find out the member forces using this formula. And then this is how I have found out member force in here, because the formula for finding out any member force is P is equal to P naught plus R into P1. For PEF, you can see that I have P naught as minus 30 and plus R into P1 or P1 into R. P1 is minus 1 over under root 2 times R is this redundant, which is 20.91. So in that way, you can find out member force in PEF. In fact, you can find out member force in any member. So this is how we find out member forces.
And because PEF is negative, it's compression.
It is compression, yes.
Sorry,
Yeah.
what is the formula to find forces in other members?
This is the same formula. This P is equal to P naught. P is equal to P naught plus P1 into R1 or R. You call it as R. In our case, R is this one. So simply you can apply this to any of the member to find out the member forces. Second part is show mathematically the effect of MM imperfection. With no imperfection, your D10 is minus 12.78. With no imperfection means that if you don't subtract this 4, D10 is going to be 12.78. And your redundant PBE is going to be 15.1. And your new force in PEF will be equal to 41.25. This is telling us that the PBE earlier was 20 and now it's 15.9. So it means that the imperfection, it increases the compressive force. Now this is 41 point. Earlier it was minus 44.78, and without imperfection it is 41.25, which means that the imperfection, it increases the compressive force, which makes sense.